So I say, that's mean. And he's like, yeah. What are you going to do, cry about it and say he's being mean to me? Right, that's what they're saying. That it would be cold. I know, you know why I did this? You know why I did this? Because the problem that, it's also good to know who's making up the test. The problem that he seems to love the most is the one that had no answer on it, none of them circled. So I put it on here.
This is not a lot. So why isn't it 2?
Okay, let's say why isn't it 2? Yes. Well, what happens when someone is the null, the condition of null? There was no intervention. Well, if there's no intervention, there should be no weight loss, right? So that's why I think the more evil thing, the more cold thing here is that the population parameter is not given to you. That to me is the cold thing here. The way to really find out. So it's not that someone's being mean, they're trying to actually figure out, do you really know what you're talking about? So this, to me, is a good question. What do you think? Population means not given.
I think
and
it's
so
hilarious.
someone's reading it. You don't know what the IOCT is, do you?
No.
We'll send you a video.
Okay.
Then you won't think it's hilarious anymore.
Oh.
Or maybe you will.
Yeah, I don't have to.
So why is the 0, right? Someone has to think, what is the null condition? What is there is no intervention. If there is no intervention, there is no weight loss. So it's 0.
Okay, so just because these trip me up. So like when I saw the 2, it was like either they lost the 2 pounds or they didn't. But you're saying it's 0 because either they had intervention.
Right. Remember, the null is that what happens without the intervention. Nothing. So to me, that's the more cold part.
Now I'm stressed about this. If we fail the midterm, will we fail the class?
That you're not allowed to say that in here.
But if I get the question wrong because I didn't even know the answer was an option, I'm going to be upset about that.
So the first thing is to start with a table so you know what everything means. Like null hypothesis means what happens if there was nothing administered. That's a null hypothesis. That's why I know what the null is, because I know what the null hypothesis means.
Okay, for our peace of mind, can you make sure that if there's no option, like the option is to circle nothing, that it says it on the exam? She doesn't need that.
Yeah, I can take it.
I don't think they're gonna do that. I voted not to have that. But that's.
So here's what I told you to do. If you missed this question, how I set this up is suggested studying is go to the online problems to do with null and alternative hypothesis and see if you can get them right. So if you missed this question, that's what I would do. All right. Second one. I didn't answer the first one, the observational units and the variables. If you were stuck on that, let me know. If the p-value is below 1, do we know there's evidence that the IOCT weight loss program works? No. So p-value, you can think of it as the percentage of data that is, they have this convoluted definition, and if you go online and look it up, you're going to get that convoluted definition, but it's literally the percentage of data in the null distribution that's above and below that distance that you found from the mean. So like 0 would be nothing happened, 2 is something happened. That's awfully little, right? So your gut should tell you this is not a good weight loss program. It probably is a great weight loss program. I don't know. But let's just say they only lost 2 pounds from it. It's not a great weight loss program. JJ left again. Hey, come on. Army of Values. I'm going to have you for PDR. Don't use bad words.
I think that saying that not answering anything on this thing on the test against the Army values. It's not going to happen. It's literally it won't happen. I promise. They're not going to give you a question. You don't search.
Okay, don't focus on that, right?
I'm still stuck on
There's this guy, his name is Keith Bauer. He explains what something is. He sits in a chair and he just says, this is what it is. And he has a nice British accent. He explains it in nice ways. 3.38 minutes long, not 55 minutes. So you can pull up that video and he'll give you a real thing of what the p-value is. And I put that link in there. And by the way, I used these videos when I first was trying to do stats because I was a mathematician who never took a stat course. So I didn't know what these things are. I can look at the formulas. I know what that is. But to really know why they're doing this, this guy is great for that. Which one would you pick here? Null hypothesis is not true. There's not much evidence. B. So some of you on your homework chose things like A. You can never say A, that it's untrue. And I had a big falling out with someone about this because they were trying to say that it's not in your class, but I had a falling out with a researcher because they said, well, it means that this is not true. Like, you can't ever say it's not true 100%. There's always a chance that the null hypothesis may be true. You can only say there's evidence for or against. So you're in a court, think of statistics as being circumstantial evidence. So you have strong circumstantial evidence or you have weak circumstantial evidence. So you can never say 100% the person's guilty. It's just circumstantial evidence. So the p-value can never tell you the null hypothesis is not true. You only have enough evidence to reject or to retain. So we select B. If you got this wrong, there's a table. I finally found the tables. It's on page 45. And the video above also talks about this. Okay, calculate the Z. I use the formula for Z. I use the standard deviation equal to the sample because I don't have the population standard deviation. I got 1.1. On page 49, I finally found that table. At the bottom, using that table, I can conclude there's little or no evidence to reject the null.
Can you do it on the board real quick?
Yeah, so it would be, think of it like this. How far away, how much weight did you lose? How far away are you from nothing? 2 minus 0, right? And the denominator is always sigma, and you're supposed to, for the t-test, you're supposed to divide by the sample size, but in the z-test, it's just sigma by itself. So when you get that, you get 1.1.
So it's 2 minus 0 divided by
1.8.
So 1.8 is the standard deviation.
Yeah.
Got it. Wait.
So this is Z. This is Z, not T.
Oh.
T has
something with the population for the letters. You have to also add that in there. That's where I'm confused.
that one.
What's the difference between those two? 'Cause I thought
This one is when you have smaller sample sizes. When you have smaller sample sizes, you use the T distribution. And the smaller the sample size, let's suppose I only had 5 of you and I ran you on the IOCT diet. That's really, the smaller this is, the strength of the evidence is going to be, it's going to be harder to convince everybody else, hey, my thing's generalized.
How do you determine if your sample is small enough to do that?
It's in the book. I think they said you can use the T for up to, usually they say about 20. Yeah.
But this was 18, so you could technically use it as well.
You shouldn't. So I think I say something like that. Okay, let's ignore the fact that we really shouldn't use the z-test here, right? And just run it through. That's the danger of statistics. You can actually run it through. So if you got this incorrect, review section 1.3, and also you should review the table that I'm going to send out to you with all the formulas in it. So just have that, and don't forget the validity conditions. We're not really allowed to use it, which is what you just said. No, I couldn't use this really. I'm supposed to use the t-test, and there's at least 20 in my sample, and it should be symmetrically distributed, the data. And I would review the table that's going to come to you on the formulas and the validity conditions, and Major Plus's table has it too. Can I use a coin to generate the null distribution? No. Answer is no here because it's not binary. It's not even categorical. We need to use an algorithm to generate the null. And so to study this, look up null distribution and simulate it. So you can use your search engine in the online version of the book. Was this sample a random sample? No. It's a convenient sample. I don't think you would do this even if I asked you to, but run the IOCT every day, 5:30 in the morning.
What is this? Okay. I'm so curious.
How many of you love the IOCT?
It's not bad. I think it's fun. It's like a series of just obstacles that you run inside and you don't upset you.
Colonel Spain's trying to get me to run that. Like, I would get stuck in that tire.
The tires, so you have to like hop a ball, climb up a wall.
All right, right skew distribution. This is what I meant. Like the kind of question, like, these are not the kind of questions, because I didn't make up the midterm, but I can find out quickly if you know or don't know something. Just knowing the definition and what the dot plot looks like is not enough. You kind of have to know what that means. And so I asked you a question like, is the median bigger than the mean here? And the answer is no, because you have those outliers to the right with a long right tail. And the mean is going to be right at, paying attention to me, JJ? The mean is going to be to hold up higher. The median, the bunch of the data is going to be packed to the left. And the median is going to be closer to that pack. So if you got that wrong, review resistance statistic, median, right skewed and left skewed.
If it's right skewed, it's going to be smaller.
Right skewed, I think someone in here said it best. The tail part is going to be longer to the right.
Yeah. So it'd be
All the data is much to the left.
So it's going to be a smaller median. And
Right.
if it's the left skewed, it'd be a bigger median.
That's correct. So, I mean, those are the kind of things when you're reviewing all that stuff and you really want to know it, you want to look up things like resistance statistic, because that tells everything. What's a type 1 error? Is that a type 1 error?
Yes.
Yes.
It is. If you got that wrong, that table, I made a table for you on a slide explaining that, and I didn't post the video yet. That you have to know cold. That table you really have to know. And I didn't upload that table yet, but there's that table in your book, which I thought was hard to read. So I think the one I made is a little easier to read. Confidence intervals. If you increase that from 95% to 99%, does the confidence interval get larger or smaller?
So it's, like the answer is yes to this, but if I have a 95% confidence interval, and I just say that it's 99%, what do you mean does the confidence interval get larger?
So the definition is that I am 95% confident that the true mean lies in that interval, right? And now I want to be I want to be even more confident. Well, that's going to force it to get wider.
Well, when it gets smaller. Oh, okay.
You're putting a more strict condition on there. I want to be even more sure.
Okay.
The only way I can be even more sure is that I have the same data that goes into this, right? Widen it.
Okay. I was just thinking like keeping the same set of like values and then just saying that I'm 99% sure.
No, you can't do that, right? With the same sample size, the same standard deviations, the same everything, you want to be now 99% sure. The only way you can do is widen it. So see what I mean? Like I know how to, I've been teaching for a long time. I know how to like ask questions so that I can see if you know something.
If you're going to calculate the confidence interval, would you just do that through R?
No, I would use the formula. Well, it depends if you can use a theory-based method, but I would use that.
Are we going to use that on the test? Do we need to know that for the test?
Yeah, and it's in your book. I bought you guys the little flags so you can tab things. I would tab all your formulas, because I don't remember formulas until I look them up again. I usually add you to Facebook after class is over, after the semester is over, but my sister just tagged me on something about forgetful people and put my name there. I forget the formulas almost the second I walk out of, and I've taught things over and over and I still forget the formulas. I look them up. All right, is a good thing if your confidence interval width is small? Is that a good thing? Yes, it's a good thing because I gave you an example in class. So the example I gave you in class was the Army Combat Fitness Test. We're only sampling people here, but I can estimate where the true population mean actually is in there with 95% confidence, and it turned out it was pretty small. So it means that when I sampled 70 students, it was probably pretty close to, being something I can generalize to. If I have a small sample size, they ask a lot of questions like this in the book. So no, you can think about this by looking at the formula. Look, if I have a small sample size, then the denominator of this guy is going to be small, and if the denominator of this guy is small, I'm subtracting more. Like 1 divided by 0.10 and 1 divided by 0.100, like 0.01 is, the smaller this bottom gets, the bigger that gets. So I can look at the formula if you're a formula person. Otherwise, you can look at the logic. If I have a small sample and it came from a bigger sample, all of it could have been to the right of the mean, right? And the only way I can encompass the mean is by stretching out the interval wider. So small sample sizes mean that my confidence intervals are going to be larger. You're all stunned by that? You have a question?
No, I'm sorry, I'm just,
Thinking it through?
yeah.
Right. So I took a sample of burgers that I'm going to, from McDonald's, that I'm going to put a average amount of calories, right? And I only took 5 burgers. It's actually hard to run this test in the lab. So I took only 5 burgers because I was lazy. And then now I'm going to tell you, well, my confidence in this is your range of calories you might 95% be expected to see if you took an average hamburger at any McDonald's around the world. Well, it's going to be pretty big, that range, because I only had 5. There's a whole bunch of problems in your book on the key ideas. Sample sizes increase. They have a whole bunch. They have it with the z-test. So I would flag all of these all at once. Those are good questions. Like someone would have to know the logic behind it. Like you either conceptually really have to know what you're talking about, or you have to know the form. You have to be a formula person. I'm more of a formula person actually, so that's why I need that Keith Bauer guy. And Keith Bauer has some. If you look up Keith Bauer confidence intervals, he'll give you a 3-minute spiel of what it is. If you want the concept, no formulas. Is my study observational or experimental? Experimental, because I gave someone an intervention. I don't have a control group, so it's not the RCT, but it's an experimental one. I showed you that table that Major Adams had. It's in the book, section 4.1, but look up these words and add them to your definition table towards the end. This is the new stuff. What's the difference between explanatory and response? Explanatory explains and contributes to the response. At most colleges, not here, we actually did that study, but most colleges, household income explains whether a person graduates or not. There's confounders, but it does explain. And then I gave you this example of a confounding variable. And this is the diagram. So income, household income, can affect the school rank because the parents get more involved in the school. That's a consequence. And it can also affect the quality of education.
Would you say to say that the confounding variable affects 2 of the can affect the other?
Not always, right? For like breastfeeding, it affects one variable and not the other. So this is like, that's why he has all those different diagrams of the way a confounder can affect things. Okay, so that's all I had on this one.